C of t was equal to 1 minus e raised power minus at, and that obviously for t greater than 0. This was equation number 2. Okay, I hope up to here there is clear. कि उसको कॉपी करके लाएं यहाँ पे जो हमने पहले किया है. Okay, just second. Just a second. Okay. Let me. Okay, this. Just a second. I will just. Okay, up to here we had done. You can see the result. First order system, we have drawn this graph. Let us say this is figure A. This is figure B. So we have derived this up to here. Okay, up to here we have derived this. Then finally we have taken the Laplace inverse and we have got the equation as C of t was 1 minus e to power of minus at, and after taking the inverse of this equation. Just a second. Yes, it is here. Why here? Okay, we have taken the inverse t greater than 0. So up to here we have already done. Now we need to look into this graph. This is a step response of a first order system. Now we will be using equations 1, 2, 3. First of all, we'll complete those equations. So up to here we have done. Now after that, we can say that where the input port at the origin will generate a forced response, that I have already told you. Input pole at origin will generate the forced response. Okay, that is CF. If we take CF of t, that is equal to 1. This is the response, forced response. Input pole will be generating, that is 1 by S. Okay, pole at the origin we have seen. And then, and the system pole is at, I talked about yesterday about the system pole at origin. We have seen that system pole is at minus A, as shown in figure 2 where we have drawn it. figure B or figure 2, this figure, yeah, this is figure B. We have drawn it, system pollet minus A. So as shown in figure B, generated the natural response. Generated the natural response. That is Cn, natural response of t is e raised power exponential responses e raised power minus at. So equation 2 can be plotted as, we will show that equation 2 plotted in the figure above. Equation 2 is plotted as above. Okay. Now let's examine the significance of the parameter A. What is the importance of the parameter? Examine the significance of parameter A. This parameter A is very important for us. Let us see, let us interpret this, what is happening with this parameter A. The only parameter that will be required to describe the transient response. This parameter is required to describe or to analyze or describe the transient response. Okay. So now let us say we will put t is equivalent to 1 by a. T is 1 by a. From equation second, what we are going to get, C of t will be equal to 1 minus e raised power minus a into t is 1 by a. So this will be 1 minus e raised power minus 1. So if you calculate that, that will be equal to 0.63. Okay, that will be calculate. We calculate that. Let's call it equation number 4. Third, I will be writing. Now, if here, third equation I will write, e raised power minus t, I will be substituting as t is equivalent to 1 by a. Okay, so then 1 by a means e raised power minus 1, and that value is become 0. The e raised power minus 1 is 0.37. Let us call it equation number 3. Now, with the help of these two equations, we can interpret the time constant, or what is happening with the response, how it is increasing or how it is decaying. Let's have a look at this diagram. Now, this is the step response of a first order system. Okay, and we will be using these 3 equations. 2 is this one, 3 is this one, and 4 is this equation. 3 and 4 equations we have obtained by substituting the value of this parameter A, which is important for us in analyzing the transient response, as t equal to 1 by A. Now here we can have a look. In this diagram, what we have a time domain analysis on this side. You can see this is a time t, and this is the response of this first order step function. This is the response. Okay, so this is response Ct. Now what's happening on this side? We have time. That means we have time period. We have divided them into 1 by a, 1, 2 by a, 3 by a, 4 by a, 5 by a. Then this side we have response. That is response C of t in terms of 0.1, 0.2, 0.3, 0.4. Just like we have got the constants here. Yes, here we have got. So in the similar way, we are putting in the points, point up to 0.9, 0.1. Now, while we are drawing this graph at time with respect to response, so curve like this we are going to obtain. So here I am this curve. Okay, with different values, we are going to get this curve. So very clearly, it has a transient response initially. Then after some time, it settles down at the value where the response value is equal to unity. Response value is equal to unity. And then there is a rise time. So rise time will start from after beginning of this curve will start to rise. So rise time will start from somewhere 0.1 and it will be between 0.9. So that time will be called as rise time. Then will we have a settling time. Settling time will be within 2% of the steady state value. This is a transient value initially, and this is a steady state value. Well, it will settle down, well, the response will settle down. So it will be within 2% of the final value. Within 2%, it will settle. Now, slope of this is, you have an initial slope that is a 1 by time constant is A. Okay. So now from this equations, this is a graph. From this equations, what we can say first definition, let us talk about the first definition, that's a time constant. Okay, so this is a time constant. How we can say, we call or we say 1 by A the time constant. So I have just now told you t we have substituted equal to 1 by A, so we call 1 by A the time constant. This is very clear. The response what we have taken, the values what we have taken, this is just an example we have taken, for example, and we have taken a step response. That means input is a step input and response what we have obtained, then we have substituted the value of t equal to 1 by A. So 1 by A will be treated as or called as a time constant of the response. This is the first thing, time constant of the response. Now first let us have from the equation third. What is this roll number 6? This is a standard charging or normal charging?
Standard charge.
Yeah, you have studied about this, so I don't need to much explain. Okay, from equation number 3, what we can say, the time constant, we have to define the time constant. The time constant can be described as the time for the response, which is what? Which is e raised power minus 80 to decay or to decrease to decay to 37% of the initial value. So this is the initial value. From here, if we are talking, it will decay to 37% of the initial value, somewhere here between 0.3 and between 0.4. So if we are talking about this, when we are substituting e raised power minus 80 t time constant 1 by A, then substituting it t equal to 1 by A, we are getting 0.37. So time constant from one definition can be defined as, time constant can be described or defined as the time for the response, that is e raised power minus t 80 to decay to 37% of the initial value. So one definition will be time constant can be defined as the time for e raised power minus 80 to decay, e raised power 80 to decay to 37% of the initial value. So this will be one definition. Okay. When I am taking e raised power minus 80 and I am substituting t equal to 1 by A. Next is, now from the equation number 4, I can describe the time constant, or I can explain the time constant as, alternatively I will say it, time constant is the time it takes for the step response to rise to 63% of the final value. From equation 4th, what I can write? The time constant is the time constant is the time it takes for the step response, because step input is there, so we call it response is also of the step response to rise to 63% of its final value. So you can see here, now 63% of final value somewhere here between 0.6 and 63% of the final value at one time constant. So you can see here, at one time constant, it's coming here. This one. This is the 63% at time constant 1. T is equivalent to 1 by A. So it has to be very clear. Time constant we can define by two ways for a standard charging equation. One will be time taken by the response, or sorry, time constant can be described in that time for e raised power minus 80 to decay to or to decrease to 37% of the initial value. Our time constant is time taken by the response to reach to or to rise to 63% of the final value. So reciprocal of time constant has the units of 1 by second. What is the reciprocal of time constant? Constant has, what are the units? It will be 1 by seconds. Time is in seconds. Reciprocal of time constant will be 1 by. So 1 by A is a time constant. Reciprocal of 1 by A is A. So unit of that will be 1 by second, or we also call 1 by second also as the frequency. We will call A as the frequency. Thus we call the parameter A the exponential frequency. Parameter A as exponential frequency. Sorry. Thus, we'll call the parameter A as the exponential frequency. So it's very clear. Now next is the time constant can also be obtained or evaluated from the pole plot. So we can see the pole plot and we can evaluate it from there. Since the pole of the transfer function is at minus A, we have seen that above. Pole of the transfer function here is at, from the graph we can see it is at minus A very clearly. So pole of the transfer function is at minus A. We can say pole is located at the reciprocal of time constant. So time constant is 1 by A. So pole is located at 1. So we have pole location at, pole of the time constant is minus A. So pole is located at, the time constant is what? Time constant is 1 by A. So pole will be located at the reciprocal at, pole is located at the reciprocal of the time constant. So this is reciprocal of time constant will provide us what? Pole location. So pole location, if we were to find, it will at the reciprocal of the time constant will be the pole location. And further the pole is from the, I have already told you, further the pole is from negative real axis farther the pole is from the negative real, or we can say, sorry, not negative, farther the pole is from the imaginary axis. We have seen last time, I also described it. From imaginary axis, faster will be the response. The faster the response, the faster the response will be. So as pole will be away from the imaginary axis, you can see imaginary axis is here. So it is on the imaginary axis, negative, it's here on the real axis. So this is negative real axis, this is positive real axis. So if pole is on the imaginary axis, far away from the imaginary axis, the response in that case will be faster. So this is for the first order. Now next is second, we have a second definition, we have a rise time. Rise time I have already explained is okay. Rise time is defined as the time for the waveform to go from point 1 to 0.9 of the 0.1 to 0.9 of its final value. Here you can see from the graph 0.1. Okay, this is 0.1. So rise time will start from here. This rise time will start from here, 0.1, and this up to here, 0.1 to 0.9 here. So rise time is what? Time for the rise time is defined as the time for the waveform to go from 0.1 to 0.9 of final value. So this is rise time is defined as the time for the waveform to go from 0.1 to 0.9 of its final value. Okay, 0.9 to 0.1 of its final. The rise time can be also solved by from the equation second. We can see that equation, response equation, C of t is equal to 1 minus e raised power minus at. Rise time is found by solving equation 2. What is equation 2? Equation 2 is C of t is equivalent to 1 minus e raised power minus at, and that is for t greater than 0. Now, so we have two times. Rise time is time defined as the time for the waveform to go from 0.1. So first time is C of t1. We can see response as 1 minus e raised power. That will be, sorry. Okay. We can write it later. First we write the times. We have to do it like this only, but let us first, because we want to clear. So first time, first response will be 0.1 because it has to rise from 0.1 to 0.9. So second will be in that case, and CT of 2 will be up to 0.9. But we know C of T1, so we have to substitute 1 minus this e raised power minus at1, because here is also t1, that is equal to what? That is equal to 0.1. So this means minus e raised power minus at1 will be equal to 0.1 minus 1, that will be equal to 0.9. So that means e raised power minus a t1 is equivalent to 0.9. So applying the log on the both sides, natural log. So log e raised power, this will be minus at log e. Log e will be 1. So that will be minus, applying natural log on both sides. So that will be minus at1 natural log of, not mine, yes, minus natural log of 0.9 minus a t1 natural log of point. If you can calculate from here, t will be somewhere, the value you are going to t1 as 0.1 by a. This is the first value you are going to get. T1 will be, after solving, you can solve this log natural, this will be minus, some value will come out here. So that will be 0.1, I think minus 0.1. So minus 0.1, T1 will be 0.1 by A. Let us call it one equation. Then second response we have C of t, C of t2 is equivalent to 0.9. We know this. So we can write it. C of t2 will be equal to what? 1 minus e raised power minus a t2 is equivalent to 0.9, or this will be e raised power minus e raised power at2 will be 0.9 minus 1. So that will be what? That will be 0.1 minus. So e raised power minus at2 will be 0.1. Again applying natural log on both sides. So what we are going to get? We are going to get minus at square natural log of 0.1. So that value I have in front of me, that you are going to get T2, you are going to get 2.3 divided by A. So you are going to get this value as 2.3 divided by A. Now we have to get rise time, hence TR, that is rise time, is equal to what? Rise time is T2 minus T1. Difference between the two. T2 is 2.3 divided by A minus 0.1 divided by A. Denominators are same, so that is 2.2 by. So if we have to get the rise time in case of the first order system, that will be 2.2 divided by A. So this is your final equation for the rise time. I hope this is clear. Roll number 6.
Yes, sir.
Okay, roll number 6, it's clear.
Yes, sir.
Okay. So next is settling time. It's very important definition there. Third definition we have, settling time. I have told you that response will settle within the 2% of the final value. That you should always remember. You मैंने network में भी कहा था. In network, I've also explained this, that whenever the transient will be there, that will rise transient, and then finally it will settle down in the steady state value within 2% of the final value. So that's what we have here. Settling time settling time, what we have, settling time is defined as the time for the response to reach and stay within 2% of its final value. Settling time is defined as the time for the response to return, that means to settle down, not return, sorry, to reach where? To reach in the steady state value and stay within 2% of its final value. So settling time, you should always remember, is the time for the response that will reach to the steady state value and that will settle within the 2%. Whatever the final value will be there, within the 2% it has to settle down. That's the settling time. So what is the expression for this one? How we can derive the expression for this one? We know. So 2% of 1 will be, we have 1 as a settling time. So 2% of that will be, so within this it has to settle down. So C of t is 0.98, substituting that in equation second. So we get what we are going to get, 0.98 will be equal to 1 minus e raised power minus a. This is we call t as ts. T will be as t will be as settling time. Okay, so that will be e raised power minus a ts. This will go on the other side, you will take it, that will 0.02, so it will be 0.02, applying the log, so ts will become 4 by ts will become 4 by a. Okay, ts is 4 by a. Fine, I hope this is clear. Roll number 10, 8. Ten is where? 9 roll number is there. Okay. Rutba, 27.
Yes, sir. Clear.
Clear? Any doubts?
Yes, sir. No, sir.
Okay, now let's have a numerical, small numericals on this one. Then we will go to the second order system. Now we have a problem number 1 here. Okay, let's do on the other page. Okay, now, actually I have not written that. I should have written that problem. Problem is that find the step response C of t for the system described by g of is equal to 4 divided by s plus 4. Also find the time constant comma, rise time and settling time. So you have to find this. Okay, just a second, give me a examination. People are calling me. So this is, so system is, hello, assalamu alaikum, sir, William. Kindness. मैं शुना क्लास चलाऊं क्या बस क्लास देऊं मैंने वुशी ग्रुपस मस कत त्रो तुई मैं छन पाई वाला मैं वुशने के मैं एस कंटिन्यूअस क्लास मैं मकल 50 3 बज थे 3 बज थे के 103 थे बकर ज्वाइन. Now we are talking about the solution of this will be, now we have to find this a first order system very clearly. There's no second degree in this case. You have to identify this is the first order system. And then what we have, so let us draw this first here. Let's draw this. Okay. So what we are having, we are the step response. So that means clearly we have a step response in a R of S. Then we have 4 divided by S plus 4 as a transfer function, G of S. Then we have to find the response. And that in that we have to find the time constant and other things. So we know C of S is equivalent to R of S into G of S. This we already know. Now R of S is 1 by S in this case because it's a step response, and step response in Laplace transform is 1 by S. That you know already. 4 divided by transfer function is 4 divided by S by 4. So therefore C of S can be written as S plus 4. Okay. Now this 4S plus 4, we can use the partial fraction for this one. A by S plus B by S plus 4. Now 4 can be written as, okay, multiplying this denominator on the other side. Sorry, this is S into S we have missed. C of S will be 1S. So multiplying this on the other side. So that will be A into S plus 4 plus B into S. So let us substitute S equal to 0. What we are getting here, 4 plus A4. So that means A will be equal to 1. Value of A we can get 1. Now put S equal to minus 4 in above. So we will be getting 4 equal to B. Sorry, yeah, B minus 4. So B we will be getting equal to minus 1. So the value of B is minus 1. Now C of S we can write, substitute these values. So above here in this equation, C of S will be A divided by, that is 1 by S minus 1 by S plus 4. Okay, first you have to take the Laplace inverse of this. Taking Laplace inverse. So C of t 1 by S is 1 minus e to the power minus 4t, and this obviously is valid for t greater than 0, t greater than equal to 0. Now first definition we have, first we have a time constant we have to find. Time constant is t is equivalent to 1 by a, we know that. We have just now got it. 1 by a is equal to here. You can say a is equal to 4 because that pole is 4, pole location, real pole. So that is 1 by 4, and that will come out to be 0.25 seconds. Second, t is equal to 1 by a is 4. This is very clear. Rise time. Rise time is tr, and we have got just derived it. It is 2.2 by a. A we know is 4. So that is 2.2 by 4, and this comes out to be 0.55 seconds. And third, we have settling time. And this is T of S, and T of S is 4 by A, and that is 4 by 4, and that should be equal to 1 second. Another problem we have, similar like this. So very simple problem. Okay. Problem number 2. Find the output response. ये क्या नाम है, तंजीब?
यस सर।
हाँ, टेक द लॉग नाउ, यही मुझे भेजो, ठीक है?
ओके।
बाद में लास्ट में देखते हैं, अभी आप भेजो। फाइंड द आउटपुट रेस्पॉन्स C of t for the system shown in figure. Also find the time constant rise time and settling time. Okay, this is given in the block diagram for you. Okay, this is 20 s plus 20. Okay, this is 20 s plus 20. So this is also very simple. I will wait. Get me the answers fast. Everybody is required to solve this in your notebooks. Solve this, please. This is also a step response. Find the output response CFT for the system shown in figure. Constant. It is given here, step response. Okay, it is given, sorry. This is C of S. It is given in the question, step response. Okay. Roll number 6, what is the answer for
Yes, sir.
output response? What is the output response?
1 minus e to the power minus 20t.
Very good. Okay. Roll number 27.
Yes, sir.
Not Adiba Shaukat. 27, not branch change. Rutba.
Assalamualaikum, sir. Yes, sir.
What's the answer for time constant?
So, minus 20.
How come it will be minus 20? It's wrong. T is 1 by A. Where is the pole at the real axis? That's at 20. How come it is minus? It is plus. To be
Plus
taken
1 by 20. Sorry, 1 by 20.
1 by 20. That is 0.05 seconds. Okay, 71. Burhan. 71. This I have already identified. He's always leaving and he will never come back. 71. Let him remove. This should be removed completely. इसको उसमें रिमूव करना है, ठीक है?
ओके सर, मैं वहां लिख दूंगा 71 एब्सेंट।
ओके, 005. Roll number 5, Uwais Rashid.
Yes, sir.
Okay, what's the rise time?
Sir,
Jaldi, jaldi. A value is 20. Rise time is TR is 2.2 by A. That is 20. 2.2 by 20. कितना हुआ हो? तुम्हें समझ नहीं आ रहा कुछ? You're not getting anything.
सर कर रहा हूँ मैं इसको सॉल्व।
इतना टाइम नहीं है. ओके, शारिक 20.
0.11 आ रहा है।
जी सर।
ओके, Okay, what is the settling time?
Sir, wait a second.
Rule number 41, Mudassir.
Sir, 0.2 settling time.
What is the settling time?
0.2.
Okay. So I need to do it or you'll do it? Tell me fast. इसको करना है आप खुद करेंगे. So this will be, कर ही देता हूँ इसको. Some people may not be comfortable. So that will be A divided by S. So 20 will be equal to, multiplying by the denominator, okay, now substituting the S equal to 0, what you are going to get? So you are going to get 20 will be equal to A20. So that means A you are going to get 1. Okay, put S equal to minus 20. That means 20 will be equal to B into minus 20. That means B will be equal to minus 1. Now substituting these values above. So C of S can be written as 1 by S minus 1 by S plus 20. So very clearly A is equal to 20 as per our formula. Okay. So taking the Laplace transform, Laplace inverse transform. So C of t will be 1 minus e raised to power minus 20t. Obviously, that is for t greater than 0. Number 1, we have time constant. Time constant t is 1 by a. That will be 1 by 20, and that is 0.05 seconds. Okay. Second is rise time. Rise time is tr, that is 2.2 by a, that is 2.2 by 20, that is 0.11 seconds. Third is settling time. Settling time is ts, and that settling time is 4 by a, 4 by 20, that is 1 by 5 is 0.2. Okay, this was another numerical, so on the based on first order system. Next we have time response of a first order system. Okay. Now, let us consider for deriving this, let's consider the first order system, or first order with unity feedback as shown in figure. Let me draw the figure. Okay. Okay, now you can see this is first order system. RS is the input, and this is a summer, plus and minus. Okay, and then this is error signal here, and this is 1 by ST. First order I am writing 1 by ST. C of S is the output, and this is the unity feedback. Now this I can write like this. RS, we know what is the formula. GS 1 plus is there, minus is there. GS 1 by 1 plus G of S H of S. So that is the formula for this solving this block diagram. So by that we will get 1 by ST plus 1. So that is C of S here. So that will be equivalent to this first order system with unity feedback. We have solved it. Formula for that: C by S of R F S is negative feedback. G of S 1 plus G of S H of S. H of S is equal to 1. So we can get 1 by 1 by ST plus 1. So now we have G of S is equivalent to 1 by ST plus 1. And now H of S already we had 1. So therefore C of S by R of S was what I have told already, G of S 1 plus G of S H of S. So you can substitute this. G of S is, sorry, not 1 S plus T, what I am writing. Okay, 1 by, okay. So this is 1 by S by T divided by 1 plus 1 by S by T multiplied by 1. I am solving this. Some people. So 1 plus ST divided by ST. So ST gets cancelled. So ST gets cancelled. So C of S by R of S is equal to 1 by ST plus 1. Now let us call this equation number 1. From here, we have to see all the three. We have to see ramp, and then we can see impulse, and we can see other responses also for this one. So next heading is response of the first order system with ramp function. Okay. So since input is the unit ramp, that is R of S is 1 by S square. C of S by R of S is 1 by ST plus 1. Okay, which implies C of S will be R of S into 1 by ST plus 1. Now unit ramp is 1 by S square. So step ramp and parabola. So ramp is 1 by S square. So we can write C of S will be, instead of 1 by R, it will be 1 by S square into ST plus 1. Okay. So this 1 by S, this we can put it in the partial fraction. That is, we can write 1 by S square ST plus 1. Okay. As we can put it equal to A divided by 1 by ST. Okay, fine. This one is, but we have a degree difference of 2. You already know it. This is BS plus C. We have to make degree difference always 1 in numerator and denominator. That's the rule of mathematics here. Okay. So multiplying by the denominator. So this will be 1 will be equal to A into S square plus BS plus C into ST plus 1. Okay. Okay. Let us call it equation number 2, and let us call this equation number 1, this side. Okay. So now substitute S is equivalent to 0 in equation number 2. So 1 will be equal to, this will become 0. C, this will become 0, 0, and this will be 1. So value of C we have got 1. So now we will be doing equating the coefficients. Now multiply this equation 1, A square, this will be BS, AS into, this will be BS plus multiplied by this BTS square. So we have multiplied with this. So this will be C plus CTS. Okay. Now we can take something common. 1 will be equal to S square, we can take common. That will be A plus BT S square. Okay, then we can take S common, B plus CT of S and plus C. Okay, so now we'll equate the coefficients. Now first we will equate the coefficients of S. Equating the coefficients of S. So once we equate the coefficients of S, on this side there are no coefficients, so B plus CT is equal to 0. That means B is equal to minus CT. C we know is already 1. So which implies B is equivalent to minus T. So we have got the value of B also. Okay, next, equating the coefficients of S square. Equating the coefficients of S square. So X square, what we have, A plus BT equal to 0. So A we have minus BT, B we have minus T. So minus T and minus T will be T square. So A value we have T square. Okay, we'll continue with this in the next class. Okay, थोड़ा time नहीं है अभी. Tanzib, you send another log, ठीक है?
Okay, sir.
You send me the log and can leave.
हो गया, sir.
हो गया? Okay. You can leave.